Okay, guys, let's look at one important rule, which is always number one to know on right angle triangles. Okay, so before I go anywhere, I want to tell you a story that was developed and that was discovered a long time ago by the man called Pythagoras. So this man he was very instrumental in the development of mathematics. What this man did on a right angle triangle, he made a square. Alright, let's just call this a square here. He made a square out of the longest side. So this is a square. Alright, assume this is a square. Okay, just want to explain this video here. That's a square. Again, he also made another square that side. So this may not look like a square, but please follow this nice story here. So when this man made this square here, okay, again another square was made from that side. So he made 3 squares out of the 3 sides of a triangle. A very good man. He was just trying to thinking and trying to see certain things. Okay, so he made this diagram here. So what he said was, let me find the area of these different sides here. So he found that the area of this guy, okay, which I'm just going to go tick, alright, was always equal to the area of this guy I'm going to call A and B. It was always equal to that. So if these are areas. Now, for example, let me give you 5 here. Follow me nicely. If this is 5, it means all the sides are 5. Let this be 4 and let that be 3, alright? What this man discovered was if I square 5, which is just like finding the area of this side, okay, this would always be equal to the square of the other 2 sides and adding them, okay, the sum of the other 2 squares. So he said this would always be equal to 3 squared plus 4 squared. If you look at this nicely, this gives you 25 equals to 9 plus 16, which is still the same as 25. So he looked at this and started looking at other right angle triangles and measured their lengths and making squares out of them. He noticed this pattern that it was always equal to that the longest side squared was always equal to the 2 squared sides, adding them or finding the sum. So he ended up coming up with a theorem called the Pythagoras Theorem. Now what the Pythagoras Theorem states is that the sum of the 2 short sides of a right angle triangle, okay, when you square each one of them, would always be equal to the longest side squared. Now, that may be a little, confusing. So let me just make this into a very nice formula here like this. Okay. Okay, let's just now look at this in a more mathematical manner. What this man said, let's take for example, we know this is a right angle triangle. Let's call this side C, A and B. So this man said, if I square C, like we looked at in my explanation earlier on, it would always be the same as A squared plus B squared. This came from the squares that I drew and I just started introducing this Pythagoras theorem. So this theorem is what is called the Pythagoras theorem. So it means that the longest side squared would always be equal to the 2 short sides, the sum of the 2 short squared sides. So this is the relationship that man found. So this relationship has now gone on to be used in mathematics in different forms. So for example, let me just give you this nice example because I love examples here. So keep this formula here. This is what we call the Pythagoras theorem, and what I explained about square boxes is where this was derived from. Okay, so let's just look at the example. Let's say I give you this side to be equal to, let's say I give you 3 centimeters and 4 centimeters, okay? And ask you to say, can you find the length of the longest side, which is C? So this formula, what this formula says is that if we square C squared would always be equal to this side here, which is squared, 3 squared, plus the 4 squared, because that's what was established by this Pythagoras guy. Alright, so it means c squared would be equal to 9 plus 16. Alright, so doing this nicely, you would find that c squared would be 25. So these are centimeters squared here, centimeter squared, centimeter squared. So this means we are going to have 25 centimeters squared. But the question is asking to say find the length of c, not c squared. It means we need to square root both sides here, alright, so that the 2 can cancel from our understanding of indices. The 2 can disappear there. Now the square root of 25 is plus or minus, but these are sides that we are looking at. They are non-negative sides. So we'll just say the square root of 25 is 5 centimeters. So it means c is 5 centimeters. So people have gone and looked at different examples. So let's look at another example on how we can use this Pythagoras theorem to find sides of a right angle triangle. So let's just look at that bit here. So let's look at this one here. Let's say the example is this. Let's say I give you this side here, alright, to be equal to 9 centimeters, and then the other side is 5 centimeters. Okay, and then I put x there, and the question says find x. So this is a right angle triangle, and any missing side can be found by using the Pythagoras theorem. So if we've been given the 2 sides here, we can find x using the Pythagoras theorem by remembering the theorem which says the longest side c is always equal to the shortest side squared plus another shortest side squared. So now in our case, this is not c, this is x, so we can just say x squared. So this is very important on right angle triangle. X squared would be equal to 9 squared plus 5 squared. Okay, so if you want, you can put centimeters there, centimeters there. So this means that x squared would be equal to 9 squared, which would give us 81, okay, 81 centimeters squared, or square centimeters, plus 25 square centimeters. So if we do that nicely here, okay, you would find that we get 106. So we'd say x squared would be equal to 106, okay, square centimeters. But then we've been asked to find x. What we've got is x squared. So if you've got x squared here, square root both sides so that the square can be dropped. So when we do this, the x would disappear there. That's just like the common way of saying things. Then you find the square root of 106. So the square root of 106 gives me 10.3, all right, centimeters. This is 10.3 to 1 decimal place. So you can see that x would now be approximately 10.3 centimeters to 1 decimal place, or 3 significant figures. So this is the importance of knowing the Pythagoras theorem. So let's continue looking at many examples on Pythagoras theorem until we understand how we use this. It's not always that we'll be asked to find the longest side. Sometimes we can be given the longest side and one of the shorter sides, or the short sides, then we would ask to find the other one. So let's look at the next example in our next video. We'll look at 4 or 5 examples to understand what we mean by the Pythagoras theorem. If you remember what I said, we said we would either be looking at finding sides, angles, or the relationship between angles and sides. So in this case, this first part, we're just looking at the relationship that exists between sides of a right angled triangle. So guys, watch out for the next video that comes with more examples on Pythagoras theorem. And please share my page and like my page on Facebook, or subscribe to my YouTube channel, which is my antenna. The next video is coming shortly.